Welcome back to Study Sprint. Today we will be exploring a topic that has changed our understanding of the physical world: the history of the atom. We will take a journey through the key developments and discoveries that have led to our modern atomic theory. Before we dive into the history, let's briefly define what an atom is. An atom is the basic unit of matter, the smallest component of an element that retains its chemical properties. Everything around us is made up of atoms, but our understanding of the atom took thousands of years to develop. If you want to learn more about the structure of an atom, you can watch my video with the title Atomic Structure and Formation of Ions. You can find the link of this video in the description. The major development in the discovery of atom came with British scientist John Dalton. In 1803, he proposed the first scientific atomic model, which is known as solid sphere model. This was the first time someone gave a scientific explanation of atoms, bringing the concept from philosophy into the realm of science. From his experiments, he suggested that substances were made up of indivisible atoms that were tiny hard spheres. He also suggested that atoms of a given element are identical in mass and properties. Dalton believed atoms cannot be created or destroyed. They can only rearrange themselves and combine with other atoms in new ways. In many ways, Dalton's ideas are still useful today. Then, in 1897, J.J. Thomson made a groundbreaking discovery. While experimenting with cathode rays, he discovered the electron, a subatomic particle with a negative charge. This shattered the idea that atoms were indivisible. Thomson proposed a plum pudding model of the atom. He thought that atoms were made of a positively charged pudding with negatively charged electrons embedded like plums in a dessert. These negative charges were originally known as corpuscles, but they commonly became known as electrons years later. Why is it called the plum pudding model? This is because at that time in England, plum pudding was a popular dessert. Although we now know this model is incorrect, but it was a step forward in understanding the internal structure of the atom. The next breakthrough in understanding the atom came about 10 years later. Ernest Rutherford, a New Zealand-born physicist, came up with the nuclear model in 1911. In 1905, Ernest Rutherford did an experiment to test the plum pudding model. From the result of his experiments, he proposed the nuclear model of the atom, which suggested that nearly all of the mass of the atom is concentrated in the center of the atom. The two students of Rutherford, Hans Geiger and Ernest Martin, directed a beam of alpha particles at a very thin piece of gold foil. They expected the particles to pass straight through the atoms of the gold foil with the diffused cloud of positive charge, as suggested in Thomson's plum pudding model. However, the results obtained from this experiment shocked them. They discovered that most of the alpha particles passed straight through the foil. Some of the alpha particles changed direction but continued through the foil. A few of the alpha particles bounced back off the gold foil. These findings led him to propose the nuclear model of the atom. Rutherford concluded that atoms are mostly empty space, with a dense, positively charged nucleus at the center. The electrons orbit around this nucleus. This was a radical shift from Thomson's model and introduced the concept of the atomic nucleus. The next important development came in 1913, when Danish physicist Niels Bohr refined Rutherford's model to introducing the idea of energy levels. Bohr's model explained many aspects of atomic behavior, particularly the light emitted by atoms. It laid the groundwork for understanding atomic spectra and quantum theory. Bohr was the first to realize that electrons travel in separate orbits around the nucleus. He realized that certain colors of light were given off when elements were exposed to flame or electric fields. This led him to believe that electrons orbit about the nucleus at different distances. He thus determined that the electrons in the different orbits have different energies. The energy is given out when excited electrons fall from a high energy level to a lower energy level. Bohr's solar system model of the atom is a way that most people think about atoms today. Finally, in 1932, James Chadwick discovered the neutron, a proton-sized neutral particle located in the nucleus alongside protons. James Chadwick bombarded beryllium atoms with alpha particles. An unknown radiation was produced. Chadwick interpreted this radiation as being composed of particles with a neutral electrical charge and the approximate mass of a proton. This particle became known as the neutron. This timeline will help you to summarize the key milestones in the history of the atom. Our understanding of the atom has evolved dramatically over the centuries. Each discovery has built on the previous one, giving us deeper insights into the building blocks of matter. And while we have come a long way, science never stops evolving. Who knows what further discoveries about the atom may lie ahead? Thanks for watching. If you found this video helpful, give it a thumbs up and share it with others. For more videos, please subscribe to my channel and don't forget to click the notification bell.